So on page 6, it looks like. 7. Page 7. Okay. So this is on page 7 of your unit handout. This is the big thing. This is what you absolutely, it's critical for Math 30-1 that you understand this. We're going to be looking at finding trigonometric ratios of angles given on the coordinate grid. In other words, sine of a rotation angle, cosine of a rotation angle, tangent of a rotation angle. And I've broken this down into 3 examples because later on when you look at the assignment questions match the examples in the order that I want you to do them. So there's a lot here. When you get to the first question I want you to do the assignment, you're going to look at it and go, I don't know what to do. It matches example number 1. So this is intended to guide you so you're successful with the problems. We're going to be finding trig ratios for rotation angles if I give you a point on the terminal arm, the coordinates of a point. We're going to be finding trig ratios if I give you the angle. And that's if I give you the special angle. So this is talking about angles that are multiples of 30 or 45 degrees. And if I give you one trigonometric ratio and enough information, you should be able to find the other trigonometric ratios. Okay? The other 2 trigonometric ratios. So to begin with, as a warm-up, we're looking at a terminal arm in quadrant 1 that passes through the point x comma y. This is what makes math -1 different than -2. If this were -2, I would say, oh, it's crossing through 3 comma 4. Here we make it general. It's crossing through any point with coordinates x comma y. What I have in bold is not crucial to this problem, but I'm just pointing out to you that this red rotation angle that I've indicated, it's a rotation angle because there's an arrow on it, is the same in value as the reference angle. How, if you knew the value of x and y, how would you find the distance from the origin to this point x comma y? We are going to call that distance r, by the way. So on your diagram in your notes it says r here. That is always the distance from the origin to a point of interest, r. It stands for radius because if you put a pen there and you started rotating that around, you'll create a circle. So if you knew the values of x and y, how could you find r? That's the question. Do you know, Cale? Do you know, Cale? What would we do to these 2 numbers to determine whatever r is? It's okay. How about you? Do you know? Who can tell me? Does anybody know? I'll give you a hint. Now does anybody know? Go for it. Pythagorean theorem. This is really a right triangle. By definition, x and y are always perpendicular measurements from the origin. They're perpendicular to each other. So this angle in here, even though nobody told you it's a 90-degree angle, it has to be a 90-degree angle. That's how the Cartesian coordinate system works. And this yellow line is x, and this blue line is y. So the answer to the question is you would take x squared plus y squared, and you would set it equal to r squared. Bless you. This is always going to be the case for any point on any terminal arm. Even if, and we're not there yet, but I'll just throw it out, even if the terminal arm ends up being in quadrant 2, 3, or 4, when you square x and you square y and add them together, you're going to get r squared. The difference is going to be if it's in quadrant 2 or 3 or 4, x and or y can be negative. But when you square them, it doesn't matter, does it? Because when you square a negative, you just get a positive. So based on this triangle that we're looking at, what is the sign of the rotation angle? Well, it's opposite over hypotenuse. But opposite over hypotenuse is a grade 10 idea. What is it here? It's y over r. And this is now what we think of as being sine of a rotation angle. It has nothing to do with opposite, nothing to do with hypotenuse. We're always going to be talking about y over r. Now, what is the cosine? Well, traditionally, cosine of a rotation angle, and I hope it's clear, everybody, that this rotation angle is in here, right? It's in that corner of what I would call the reference triangle. Well, adjacent is x and hypotenuse is r, so cosine is x over r. When we talk about tangent in grade 10, we say tangent is opposite over adjacent, but there is no opposite in adjacent. There is, however, a y and an x. What we are doing, I guess, is associating y with opposite and x with adjacent and r with the hypotenuse. You physics 20 people, that's why if you draw vectors above or below the horizontal, which means the angle you're using is a reference angle, that's why cosine will give you x and sine will give you y. It's set up that way intentionally. All right, nothing more to see here. What is true about the nature of the three trigonometric ratios for any terminal arm that lands in quadrant 1? I'm going to rephrase that. What is true about sine of theta, cos of theta, and tan of theta as long as theta is between 0 and 90 degrees? Well, if you take a look at the definitions of these things, sine is y over r, but in quadrant 1, y is always positive, right? R, everybody, is always positive. R is a distance. It doesn't matter which quadrant it's in. So what we're talking about in quadrant 1 is this scenario, right? And for cosine in quadrant 1, x is positive, and r is always positive. And in quadrant 1, x and y are both positive. And this is kind of overkill here. What I'm saying is everything is positive, so these three trig ratios are positive. Let's write that down as an answer, that cosine of theta, if this is the case, if this is the case, cosine of theta will always be positive, sine of theta will always be positive, tan of theta will always be positive. We do not have time with this lesson to do a whole bunch of calculator work, but just think about what I'm saying. If you picked any angle that's bigger than 0 degrees and less than 90, and you took the sine of it or the cosine of it or the tangent of it, you will get a positive number, okay? Trust me on that. Sketch a rotation angle in standard position if the terminal arm is located in quadrant 2. Well, just draw any terminal arm in quadrant 2. We need to label the angle. That's theta. And then it says, use a reference triangle to write an expression for these three. So what we are going to do is add to this diagram a point and a reference triangle is formed by dropping, in this case, from the point to the x-axis and creating a right triangle. This will be your reference triangle. Where this is your reference angle. Now, this is tricky. It's slippery mentally. The theta in sine of theta is not the reference triangle or the reference angle. It's theta. It's the red theta. But we're going to use the reference triangle to define the sine. So we look at this and we look at the opposite side. It's a miracle. The opposite side is still y. And the adjacent side is still x. So this is y, and this is x, and of course this distance is r. So based on that triangle, what is sine of theta? The same thing it was before. And I can tell you right now, sine of theta is always going to be, can you put that down in focus, please? The sine of theta is always going to be y over r. It doesn't matter what theta is. It can be 0, it can be negative 10 million, it can be in quadrant 1, 2, 3, or 4. Sine of theta is y over r. Again, y is replaced opposite, and r has replaced hypotenuse. Cosine, looking at the reference triangle, is x over r. Tangent is opposite over adjacent, which is y over x. They're the same things that we put for the first part of this warm-up. Is everybody with me here? Okay, but so these are definitions now. What? Well, I guess I never really ask it, but I'm going to ask it here. Do you have a C? Okay, well, let's ask the same thing. What can you tell us about the positiveness or negativeness? Well, in quadrant 2, y is positive and x is negative. And just think about that. Look in quadrant 2, pick a point in quadrant 2. X will be a negative number, y will be a positive number. R is always positive, which means in quadrant 2, sine of theta is positive, cos of theta is negative. Right? Negative divided by a positive gives negative. And tan of theta is negative. Positive over negative is negative. I mean, what's an angle in quadrant 2? 90.1 degrees is in quadrant 2. Sine of 90.1 is positive. Cosine of 90.1 is negative. Tangent of 90.1, whoops. Tangent of 90.1 is negative. Don't worry about the size of the numbers. That requires a different lesson. This can be continued for the other quadrants. I'm going to show you something now that's in your textbook. You don't need to write this down. Here's what we learned in this part of the lesson. The y-coordinate is always associated with opposite. The x is always associated with adjacent. And r becomes the hypotenuse. The x and y coordinates can either be positive or negative depending on the quadrants. So I think now I'm going to show you something that's in your textbook. You don't need to write this down. It's in your textbook. Just focus up here. If we're talking about quadrant 1, everything is positive, right? If I go to quadrant 2, y is positive, r is positive, and x is negative. So you would use that knowledge to tell me whether tangent's positive or negative. And you would say, well, I know tangent's y over x. If I take a positive divided by a negative, I get negative. If I extend this into quadrant 3, x and y are both negative. I want that to sink in. That any terminal arm in quadrant 3 will have a negative x coordinate for the point and a negative y coordinate, which means tangent is positive because it's y over x. And if they're both negative, you've got a negative divided by a negative. And the reason why I don't want you to write this down, I don't even include it in your notes, I think this is just thinking about what's going on. If I asked you what's going on in quadrant 4, everybody should be capable of drawing that and seeing that x is positive and y is negative. All right, we're going to come back and use that in a bit. But what's happened is this. This is what has happened. So if you turn the page now, this is grade 10, right? We learned this in grade 10. Now it's out the window, and this is what we use instead. Don't get me wrong. We would still use this if you had a triangle and a problem in math where you had an angle of elevation to the top of the mast of a ship, and you were trying to find something else, maybe how far away the ship is. You would still use this, but in terms of coordinate trigonometry, this is what we're talking about. This is on your formula sheet. So in grade 10, we give students this on the formula sheet. Grade 11, we give them this. Grade 12, we don't give them anything in terms of these definitions. They need to know it. So let's look at some examples. So you'll notice here it says for similar examples, I'm also directing you to similar examples in your textbook. So when you get to the assignment's pointing to these examples, but these examples are also pointing to stuff in your textbook if you need extra practice. The point 5, 12 lies on the terminal arm of a rotation angle theta. What is the value of sine of theta? What is the value of cos of theta? What's the value of tan of theta? This is easy. It does not take long. It's really simple. Because you know, hopefully you don't have to look at a formula sheet, but if you do, it's there. You know that this is how we calculate those three trig ratios. And if the terminal arm passes through the point 5, 12, you know that x is 5 when y is 12. So, by the way, we know the tangent of theta. It's 12 over 5. Because we know y and x. Tangent of rotation angle theta has a value of 12 over 5. If you knew what theta was, and you went tangent of theta, your calculator would spit out 2.4, which is 12 over 5. Now, what is preventing us from finding the sine of the rotation angle and the cosine of the rotation angle? Well, we don't know r. But x squared plus y squared equals r squared. Let me explain something to you. This is the only Math 20-1 idea that we're using to answer this question. That's it. When we look at x squared plus y squared equals r squared, I know you could argue that that's a Math 20 idea, but it's the Pythagorean theorem, which you learn, I don't know, grade 1? No, maybe not grade 1, but you've learned and known about the Pythagorean theorem for some number of years. So we put in 5 squared plus 12 squared equals r squared. I believe this is 169 is what I'm getting. So r is equal to, not quite sure what happened there. So r is equal to root 169, which is 13. For you physics 20 students, it's 13, yes? Okay. You don't go plus or minus here, you physics people, because there's no meaning behind the negative. R is a distance. So now that we know r is 13, I guess I can add it to my list up here just so we can see it. Sine is 12 over 13. Cos is 5 over 13. And we're done. That's it. We just need to find r so we could write out what the three things are. Any questions with 1a? B, the point -8, 15 lies on the terminal arm. By the way, -8, 15 would be in quadrant 2. 8 to the left, 15 up. I hope it's clear that since sine and cosine of the rotation angle by definition are something divided by r, you need to find r. Which means we go x squared plus y squared equals r squared. Is that 289? Yes? I'm pretty sure the square root of 289 is 17. Thank you. So r is 17. This just becomes like taking candy away from that tired baby. It's really simple. 15 over 17 for sine of theta. Cos of theta is -8 over 15. No, over 17. Now, tan of theta Tan of theta is y over x. So it's negative 15 over 8. Now, I know that some of you might go, wait a minute, you just said y over x. Isn't that 15 over negative 8? Yes, it is. You could have written 15 over negative 8. I would much rather write a number, and the tangent of theta is a number. It's a ratio of two numbers, but together they form a number. I would much rather write a negative fraction with the negative in the numerator. My second choice would be to write it in the denominator, and my absolute last choice that I would ever use is this. And unfortunately, that's how things get typed in textbooks and on exams. That negative is meaningless there. It just tells you the whole thing is negative. But in terms of operations, you need to put it on the top or put it on the bottom. And I just prefer it on the top. Questions with B? Determine the exact value of each of the following. I want to know the exact value. Well, we're going to sketch this. So this is not about x, y, and r directly. And hopefully, I'll give you a second to think about where that terminal arm will lie, and more importantly, about what the reference angle will be. I would say quadrant 3, 60 degrees below the x-axis. So we're looking at this. That's 240 degrees. Now, how do we find the exact value? Well, sine is y over r, right? We need a y and an r. Well, here's how we get it. I'm going to crank this mine down a bit more. You don't need to change yours. What you are going to do is draw your reference triangle, which looks like that. And you're going to go, oh, okay. This is 60 degrees in here. This is 30 degrees in there. I recognize that special triangle. That triangle has a hypotenuse of 2. The short side is 1, and this is root 3. So what is y? Well, root 3. Kind of. Not really. I'm just going to say y is root 3. Over r, which is 2, except it's in quadrant 3, so y is negative root 3. This is the exact value of sine of 240. Exact. So how would we do this? Well, we have to sketch this so that we can identify the reference angle so we can draw in the special triangle. 315 is 45 degrees away from being 360. So the terminal arm lies in quadrant 4. I don't know why, spatially, I just can never, maybe because it's not, I'm looking at it sideways. I don't know, I'm going to go with that. Here is our reference triangle. It is a 45, 45, 90 degree triangle. The hypotenuse is 2, and each of these sides is root 2. So what is cosine? Cosine is x, which is root 2, over r, which is 2. In that quadrant, is x truly positive root 2? Yes. If you want to be fancy, you could really do this. Right? It's just that it kind of breaks down because those numbers are no longer lengths. But that's okay. Question? Okay. All right. We got a couple more examples to look at. An angle has its terminal arm in quadrant 4. You may think that this is unimportant. And man, there are a boatload of questions in high school math where they tell you information in the question that is unimportant. I call that parsley sprinkled on the fish. It doesn't do a thing for the meal. It's just appearance. But this is important. Cosine of theta is 9 over 41. What's sine of theta and what's tan of theta? Okay. Well, let's start at the end with what we want to find. We want to find sine of theta, and we want to find tan of theta. I hope it's clear that we need to know for sine of theta, y and r, and for cos of theta, or tan of theta, we need to know y and x. Now, since cos of theta is x over r, we can associate this 9 with x and this 41 with r. And I just want to touch on one little thing here because some top-end students, it will occur to them and they'll start questioning what they're doing. Do I know for sure that x is 9 and r is 41? No. Maybe x is 18 and r is 82. It's the ratio of the things that matter. And if you use 18 and 82 and you find y, then you will get two numbers that are twice as great over here for y and r, and it'll reduce down to what you would get if you just chose 9 and 41. So don't forget this arm extends forever. There's a million points on it. We're just picking one point where x is 9 and r is 41. So that means, well, we know some of this stuff now, don't we? We know r is 41. We know x is 9. I guess what we're missing is y. Oh, well, that's okay, because x squared plus y squared equals r squared. And I think I've designed this question so that all of the numbers we use in this lesson are what we call Pythagorean triples, which means like it's 3, 4, 5, 5, 12, 13. You don't get decimals. The difference here, I hope it's obvious, is you have to take 41 squared and subtract 9 squared to get y squared. We're not adding them. And all I need to know to begin with from somebody once you've got it is what is 41 squared minus 9 squared? We got it?
40.
1600 you mean? Before you take the square root. Yeah, okay, good. So 1600. So I'm going to finish the problem and then I'm going to ask you a question. It's a really important question. It's crucial. So that means y equals the square root of 1600. And that means y equals, as was said, 40. Right? Okay. That means sine is 40 over 41 and tan is 40 over 9. Are you with me? Here's the question. Why is that wrong? Because it's not right. It's in quadrant 4 exactly. In quadrant 4, y is negative. That piece of information was crucial. Y is negative down here. So those of you that are in my Physics 20 class, you already have a heads up on this. We've already talked about this. That when I say y squared is 1600, and we do this bit of business here to find y, it's not finding every value of y. If I square 40, do I get 1600? Yes. But if I square negative 40, I get 1600. So when you take the square root now, and I might be mixing up my classes, but I don't think we've talked about this in math class yet. Have we? We talked about it in my physics class. we have to, whenever we take the square root, go plus or minus. And that tells us that it could be positive 40 or negative 40. And then it's your responsibility, that's your burden to go, well, which one is it? It's negative. Okay? So that means, since it's in quadrant 4, these are our answers. Yeah, of course. Capiche? We have one last example. What is sine of theta and cos of theta if tan of theta is 8/3? Okay, so sine of theta is y over r. Cos of theta is x over r. We need to know x, y, and r. We need to know those three things. But I also know that tangent of theta is y over x. So just like the previous question, that means I can associate the top of this fraction with y and the bottom with x. So, well, I guess we know y. We know x. We do not know r. So what's r? Well, we're going to go x squared plus y squared. I guess I lied. This is not going to be a perfect Pythagorean triple. When you figure out what 8 squared plus 3 squared is, do you get 73? Okay. So we are in the land of exact values in Math 20-1 right now anyway. 73 is not a perfect square, so that means r is equal to root 73. Exactly root 73, and that's r. Okay, well, hang on a second. Shouldn't I put plus or minus? I guess I should. I really should. But r is always greater than 0. We don't need to consider that here. I mean, you could say it's either positive root 73 or negative root 73, but we're just going to say positive root 73. So, sine of the rotation angle is 8 over root 73, and cosine is 3 over root 73. Are you with me? Okay, you're one step ahead of me. What's wrong, Sukman? Right. Actually, and negative 3. Because tangent is y over x, in quadrant 3, where x is negative and y is negative, we don't see the negatives in the 8/3. Because what somebody has actually done is they've taken the negative 8, which is the y, and the negative 3, which is the x. They've divided them, and the negatives disappear. Now, that doesn't affect what you get for r, because when you square those negatives, they're going to go away. So the negatives never appear in this question mathematically. They have to appear, and I don't know if you noticed this, when I read the question, I intentionally didn't mention that. I just said, oh, okay, let's get going. That is important. It is not parsley on the fish. It's the fish. It's the meal. So, these are our answers. This middle layer to our lesson sandwich today, number 2, is important, but it's minimally important. It's not as important as this layer where we're working with x, y, and r, example 1, or certainly this layer where we're working with x, y, and r. So I want you doing these in the order that I'm listing them. I know 2 comes before 3, but 3 matches example 1, 2 matches example 2. It's kind of guiding you to be successful here. So you have about, I think, about 15 minutes or so to work on these. Really, the bottom line, do I have a nice summary up here? This is it. This is what's important.